Metagenomic sequencing was really developed for research purposes because there's a lot of data to deal with. A lot of the microbes that come up on metagenomic sequencing, you'll see these lists of hundreds of microbes in the microbiome. We don't really know what most of them do. They haven't really been well studied. And that's really important when it comes to clinical interpretation. When you're looking at microbes that can inform clinical decisions, you want to know something about those microbes. You want to know what they're linked to. You want to know something about what you can do about them, what sorts of things they're doing in the gut. The gold standard for detecting these types of pathogens is quantitative PCR. One of the advantages of quantitative PCR, it allows you to focus in on the microbes that are most clinically relevant. Based on the research, when it comes down to specifics, specific pathogens, for example, specific opportunists, a lot of these important microbes that we think of as pathogens and opportunists are low abundance. So they can be present at amounts in the microbiome that are far lower than the typical commensal microbes, and yet they can still cause a lot of problems, even though they may be present at 1,000,000 times lower in concentration, because they can do kind of a lot of damage in the gut. That's where qPCR shines. It was specifically developed to be able to zero in on these particular pathogens and opportunists and other important microbes, so you can kind of identify those needles in the haystack.